These notes are from section 3.1, which is titled Extrema on an Interval. We are going to define two different types of extrema today, absolute extrema as well as relative extrema. We will focus on how to find an absolute extreme value. So when we talk about an extreme value, we're talking about the minimum and maximum values. If we have the very highest or the very lowest point on the entire interval that is given, that is the absolute extreme. So the very highest point is called the absolute maximum, and the very lowest point is called the absolute minimum. For a relative extreme value, it does not necessarily have to be the very highest or lowest point on the entire interval. It just needs to be the highest or the lowest point, the maximum or minimum in its general vicinity. So if I have a graph that looks something like this, hold on. My graph looks something like that. I think we can all agree that this is the absolute maximum value. It is the very highest point on the entire graph. This point here is not the highest point on the entire graph, but it is the highest point in its general vicinity. If I move to the left and to the right from that point, it goes down in both directions. So this would be considered a relative maximum value. This point right here is a relative minimum. It's also important to note that if we happen to have an undefined point where the maximum or minimum would otherwise occur, that is not a maximum or minimum. So if I have a graph and there is a hole at this point right there at the vertex, and suppose my graph, this is a y value of 7. Well, I can't say 7's the absolute maximum because I don't have a point that has a y value of 7. But we also can't say 6 is the absolute maximum because there's points higher than that. And we can't say 6.9 because there's points higher than that, or 6.99. It gets infinitely close to 7 but never reaches it. In this case, we say there is no absolute maximum value. And that's a rare case. Most of the time that does not happen. So example one, we were given a graph and we were asked to find the absolute and local. The word local means in that area. That's the same thing as relative extrema of the graph of g of x. Find the absolute and local extrema of g of x, and we are given a graph of g of x. It looks like this. So we have a defined point at this endpoint. We have an undefined point at this endpoint. It comes up and reaches this sharp curve and goes down. Notice the derivative does not exist at that point right there. We have a vertex down here at 0, 2. But the derivative does exist at that point. I could sketch in a tangent line. It would be a horizontal tangent line. And then it goes up from there to this undefined point. So first let's list any absolute minimum or maximum values. So the absolute minimum is this point right here. That is the point 0, -2. It has an absolute minimum value of -2. When we report extrema, generally we report the y value. You could also list it as a word pair. That would be fine. The absolute maximum, the very highest point on the graph, if it were defined, would be this point right here. Because it is undefined, we say that there is no absolute maximum. We can't say that's the absolute maximum because we have points higher. It gets infinitely close to 7, but never quite reaches it. when we list relative extrema, we are just looking to the left or to the right of that value and checking to see if there are any points lower than that, or if I'm looking for an absolute maximum, any points higher than that. So notice this point right here, if I go left and right, it only goes up. This is the lowest point in its general area. We have a relative minimum at -2. We also have a relative minimum right here at 1. And we have one relative maximum. It is at this point right here, 5. In 3.1, we are focusing on how to find absolute extrema. So we will be given an interval. So in this case, our interval would go from 2, 3, 4, -5 to 4. And we would want to find the absolute minimum and the absolute maximum values. But instead of being given a graph, we are most often going to be given an equation. So there are 3 places that absolute extrema can occur. The first, notice we had an absolute minimum right down here. Absolute minimum at that point. Notice at that point, the derivative is 0. If the derivative is 0, that means that there is a chance that I could stop and turn and go in the other direction. And that could potentially, if that's the lowest point on the entire graph, that could give me an absolute minimum. So the first place that an absolute extreme value could occur is where the derivative is 0. We had no absolute maximum here, but suppose my graph looked like this, and it just stops at that endpoint right there. Notice now my absolute maximum value is this point right here. The derivative is not 0 at that point. The derivative is undefined at that point. If the derivative is undefined, we could have a point where it reaches a sharp curve, stops, turns, and goes in the other direction. That could potentially be an absolute maximum or an absolute minimum as well. So the first type was if the derivative is 0. The second type is if the derivative is undefined. So we could have absolute extrema where the derivative is 0, where the derivative is undefined, or the third possibility, notice if this point, it kind of looks like the derivative is 0 at that point, so I'm going to change it just a little bit. If my graph were to look something like this, notice at that point, I would now have an absolute maximum of this value, even though the derivative's not 0 or undefined. Maybe the graph continues on, but I'm looking at just that interval. So that third option is the endpoint of the interval, where the derivative is 0, where the derivative is undefined, or we could have absolute extrema at one of the endpoints of the interval. These first 2 circumstances where the derivative is 0 or undefined, these are called critical numbers or critical values. The derivative is 0 or undefined is called critical numbers. Absolute extrema can only occur at critical numbers or at the endpoints of the interval. So to find absolute extrema, what we're going to do, the first thing we're going to do is need to find those critical numbers. We need to take the derivative, set it equal to 0, solve, and don't forget to consider where the derivative might be undefined. If the derivative is undefined, we could potentially have absolute mins or maxes there as well. We are then going to test the critical values as well as the endpoints of the interval, and we are testing them back into the original equation. Basically, we're getting the y value of all the possible points we might have absolute extrema. And then step 3, we need to identify the absolute maximum and the absolute minimum. The maximum's just the biggest of those y values, and the minimum is the lowest of those y values. So example 2, we are given an equation, f of x equals 3x to the 4th minus 4x cubed. And we are asked to find the absolute extrema on the interval from -1 to 2. Find the absolute extrema on the interval from -1 to 2. Absolute extrema only occur at critical numbers or at the endpoints of the interval. We know the endpoints of the interval -1 and 2, so we need to find the critical numbers. Critical numbers occur when the derivative is 0 or undefined. So let's get the derivative. 12x cubed minus 12x squared. We're setting the derivative equal to 0 and solving. So I am going to factor out a 12x squared. Set each factor equal to 0. And I get critical numbers of 0 and 1. Don't forget to consider where the derivative might be undefined. In this case, I'm not dividing by any x's. I don't have a piecewise function. So the derivative in this case is never undefined. Step 2 said to test the critical numbers, so 0 and 1, as well as the endpoints of the interval, -1 and 2, back into the original equation. So we're going to make an xy chart, or an f of x chart. It is important to label your chart because we're going to be doing other charts that have something other than f of x soon enough. We are plugging in our critical numbers, 0 and 1, for x. We are also plugging in both endpoints of the interval, -1 and 2, for x. And we are plugging them into f of x. So plugging in -1 gives me 3 plus 4. Plugging in 0 gives me 0. 1 gives me -1. And 2 gives me 3 times 16 minus 4 times 8 gives me 16. So I take all my x values, I plug them all back into the original equation. These are the only possible points where I could have absolute extrema. So even though there's an infinite number of other values in between these integers, we could only have them at the endpoints or where the derivative is 0. So our absolute maximum is the highest of the y values, 16, and our absolute minimum is the lowest, which is -1. Example 3, find the absolute extrema on the interval from -1 to 3, and we are given g of x equals 2x minus 3x to the 2/3. Anytime it asks us to find extrema, for now absolute extrema, we will be finding the derivative. Setting it equal to 0. Negative exponent, I move down to the bottom. X to the 1/3 is the same thing as the cube root of x. I'm going to add this over and solve for x. So I added this over to this side. I multiply both sides by cube root of x, divide by 2, and I get x equals 1. Don't forget to consider where the derivative might be undefined. If the derivative is undefined, you could have a sharp curve, which could be an absolute minimum or an absolute maximum value. So to check where the derivative is undefined, we want to check to see, does the derivative have any x's in the denominator? It does. And if so, I set that equal to 0. Because if the denominator is 0, dividing by 0 is no good. That would be when the derivative is undefined. So notice I get critical values of 0 and 1 this time. 0 and 1. The critical numbers are not always 0 and 1. I realized they were on the last one. We set up our chart. We make sure we label it. We plug in the critical numbers for x, as well as the endpoints of the interval. And we are plugging back into the original equation. Plugging in -1 gives me -2 minus 3. Plugging in 0 gives me 0. Plugging in 1 gives me -1. And 3 we could approximate. Let's go ahead and use our calculator here. So plugging it back into the original equation here gives me -0.240. Absolute maximum value is the biggest y value, 0. Absolute minimum value is the smallest one, -5. That is it for today's notes. Reach out if you have any questions.